Here we go. 14G, the intro. Your job in exercise 14G is to solve an equation. So you needed to know symmetry properties and exact values. If you don't know all the exact values yet, use the table. So use it to guide you first, okay? But let's do this problem first. Question 1, or example 1 says, you got an equation. Sine of x is equal to root 3 on 2. We're trying to solve for x. I want to know what x is, okay? That's my goal. And all I know is that x, which represents the angle, okay, so the angle, I don't know what the angle is, but they said the angle is between 0 and 2 pi. What does 0 and 2 pi mean? Remember, when you start your circle, you're starting here, right? So right at this point, that's 0 degrees or 0 radians. If I rotate from 0 to 2 pi, this is now pi on 2. That is pi. An extra half is now 3 over 2, so 3 pi on 2, and then 2 pi. So what am I saying? I'm doing one revolution, making one circle, okay? In one circle, that's all my possible angles, so 0 to 360 degrees is what that's saying. But we're working in radians now, so instead of saying 0 to 360 degrees, okay, and I'm going anti-clockwise, like that, we're just saying 0 to 2 pi. So the angle in this, I'm rotating one full circle. When will sine equal to root 3 on 2? Now let's think about, let's break the things we understand so far. What does sine represent again? X, Y, or gradient? Which one is it? Y. This is representing the Y coordinates. So what I'm saying is, when I rotate 360 degrees, so I rotate 360, when will I have a Y value that is positive? Root 3 on 2. Now forget about the root 3 on 2. Don't worry about the number. Just think about the sign. I'm saying when is it positive? Root 3 on 2. Now looking at just this. Which quadrants will I have a Y value that's going to be positive? 1 and 2. These are the only two. This is where Y is positive. The Y axis is positive only here. But which quadrants, which means on the circle, which dots will have a positive Y value? It's only either dots over here, anywhere there, or anywhere here. So it has to be quadrant 2 or quadrant 1. Okay, that's where your ASTC comes in. Yeah, so all sides are positive, and then only sine is positive here. So you can memorize ASTC, or you just think about it logically. Y value is only positive quadrant 1, quadrant 2. So that's the first step, figuring out which quadrants am I focused in. So this is my problem. I don't know where the coordinate is. I have no idea where the coordinate is. So it's x, y. But what I do know is it should be root 3 on 2. The y value is root 3 on 2. Okay, so the height is root 3 on 2. Here we go. So I draw the triangle. This is root 3 on 2 height. That's root 3 on 2 height. That's the only two sections where I'm going to get a root 3 on 2. What you now need to know, so first step was which quadrant? So we've got these two quadrants. We know it's one of these 2 points. What we don't know is what x is. Because we said rotated by x, right? X is an angle between 0 and 2 pi. So it could have been an acute angle, so like that. Or it could have been an obtuse angle, which is from here to here. So I don't know what the angle is. But this is where your exact values come in. You can then say, well, actually, I do know an acute angle. That sine of some angle, this is where you have to go back to your exact values. Sine of what angle gives you root 3 on 2? That's the second step. You can use your tables if you need, but those who can remember. So first step was step 1. I'm going to write here. Step 1 was which quadrant? So you do quadrant, question mark. Okay. Step 2 was what's the base angle? Well, they call it reference angle. Because the one that we learnt so far is exact values. So they always have to be in that acute section. Now, this question. We know it was Q1, Q2. So quadrant 1, quadrant 2. Sine of what angle, going through your notes or remembering your hand method, which angle will give you sine having root 3? Because you need 3 fingers for sine, yeah? So square root of the number of fingers and then divide it by 2. So which angle gives you 3 fingers for sine? Yeah, 60 degrees. It's your ring finger if you're using your left hand like I am, yeah? So it's your ring finger, 3 fingers for sine. That means this is 60 degrees, or what's the radians? Pi over 3. Very good. Because it goes from 6, 4, 3, 2. Gets smaller. So in terms of the hand method, I'm just going to draw the hand to help you visualize. Remember, we wanted 3 fingers for sine. Sine is on the left. So I needed 1, 2, 3. That means this finger is the one that's the angle that I need. That angle there is 0, 30, 45. So that finger has to be 60. And remember the pi radians, it goes from 6, so pi and 6, so 0, 0, pi and 6, to pi and 4, to pi and 3. So the numbers go down. Okay, so that's just the exact value. So that's what I meant. That revises your exact values. So we know pi and 3 is the angle that we want. So I'm going to write it in. So we know this distance, remember radians is the distance on the outside. So let's focus on the circle again. That means when I started at 0 and I rotated, I would need to rotate pi on 3 in order for sine to be root 3 on 2. Because we know that sine of pi on 3 is going to give you root 3 on 2. And it's positive. That's using exact values. So we only use the acute angle. We just use quadrant 1. And we already know a fact that when it's pi on 3, I will get a positive root 3 on 2. Now, you only need one angle to then figure out all the other quadrants. That's why it's called symmetry properties, because we're using symmetry to figure it out. So if this is pi on 3 this way, notice these 2 triangles that I've drawn, these 2 triangles, they're equivalent. They're congruent. Those 2 triangles are the same. They both have root 3 on 2 height, root 3 on 2 height. They're both right angled. So that means if that height's the same and that height's the same, we can say from here to here is also pi and 3. Okay? Now if we know that, this is how we answer the question. When I rotated, so think about it. When I started from 0, I went up by pi and 3 and I hit my first solution. The angle is 30 degrees, 60 degrees, and that's my first answer. So when we say sine of what angle gives you root 3 on 2, you already have $60 degrees, or you're meant to write pi and 3, because we can see it was 0, that's where I'm starting, and I moved by pi and 3. So that's one of my answers. Pi and 3 is possible one answer to get root 3 on 2. Or, so once I rotate here, that's one answer that I could get. But then if I had to rotate from 0 all the way here, that's an obtuse angle. So what is that angle to work out? Well, we can use a bit of fractions here. See, all the way is pi. I'm only short of pi by pi and 3. So how do I calculate that full angle on a fractional point? I'm asking, what is it from here to here? How much is it from there to there? So think about it. To get all the way here, it has to be pi, which is 3 pi on 3. 3 out of 3. Yeah, 3 out of 3 makes 1 whole. But if I'm 1 less, then what's this one? What's the distance? 120. Or, in terms of angles, it's 2 pi on 3. Yeah, so you got to work with both. So you're right. If that's 60 here, you're right. This is 120. But how did you get 120? You would have done 180 degrees, take away 60. That's how you knew 120. In terms of radians, it would have been pi minus pi and 3. This is where students need to get better at fractions. So pi minus pi and 3, because we know all the way here was pi, and then just short of that, going backwards by pi and 3 means pi minus pi and 3. Working on fractions, that's the same thing as writing 3 pi over 3, take away pi on 3, gives you an answer of 2/3. Because if this is 1/3, well, of course this is 2/3 to make 1. So what's my answer That literally is my answer. My answer for x is equal to, you could have pi on 3 to get root 3, or you can have 2 pi on 3 as my possible answers. Can you see what I'm doing there? I'm only doing two things there. I'm using unit circle, knowledge of unit circle, and then I'm using exact values and symmetry properties. So there's only two sections, but that's why if you can do 14G, you've done a lot of the skills that I need you to learn. Yeah, so the hard part is understanding, why did I do pi minus pi on 3? Well, why did you get 120? See, logically, you knew there was 180, half a circle. You got to work in radians now. Half a circle is pi. Short of pi, pi on 3. So pi minus pi on 3 gives me 2/3. It's 1/3 up here, so 2/3 is this way. Okay? Why did I choose those two quadrants? Because sign was positive. So your ASTC tells you which quadrants are going to be positive. So I knew quadrant 1, quadrant 2, and when I rotate it, well, it's only these two. I don't care about the bottom two, because the bottom two y value is going to be negative, so it can't be one of the solutions. That's why if you use your CAS, if I go back to my CAS and I typed in sine of pi over 3, I get root 3 on 2. The other one was sine of 2 pi on 3, and I get root 3 on 2. They're both positive. So I answered the question. The question was, what is x to get there? And I found it. Pi on 3 and 2 pi on 3 in one revolution. What you practice in 14G is that they might change the number of revolutions. You could do 2 revolutions. You could do 3 revolutions. And the more revolutions you do, the more possible intercepts you can get. Okay? Layout. How do you lay it out? Notice I wrote sine inverse over here, because back in year 7, our goal is to find x. How do you get rid of sine? Well, the inverse of sine is sine inverse. Sine inverse to the left. Whatever you do to the left, you must do to the right. So I do sine inverse on the right. That's why the sine and the sine cancels out. That's why I'm left with x, kind of like your log and exponential. When you do exponential, you do log, they're inverses, they cancel out. That's why I wrote here, x will equal to sine inverse of root 3 on 2. In a language sense, this is the same thing as asking, what angle will make sine root 3 on 2? And that's why you have to know your exact values. So those who were able to figure out using the hand method or whatever method, you knew it was 60 degrees, but you had to know that in radians. So I said, yeah, using your exact values, we figured out it was the ring finger, had to be 60 degrees or pi on 3. And so then I went back to the unit circle and said, all right, well, if it's pi on 3, so from here to here, quadrant 1 and quadrant 2, that's pi on 3 this way. But then I can also go pi on 3 this way to get the same height, same y value. So if I can go pi on 3 backwards and pi on 3 forwards, 0 plus pi on 3 gets me the first solution. And this one was pi minus pi on 3 to get my second solution. If it was down in quadrant 3, then I would have added. I would have said pi plus pi on 3. If it was in quadrant 4, and I knew I went down by pi on 3, or it was just pi on 3 less, then I'd say 2 pi minus pi on 3. And that's the skill that you're working through. You're working through the unit circle, and knowing pi, all the odd pi's on one end and all the even pi's on one end, that's why it's beneficial. That means you can go up to 99 pi, no matter how many revolutions that is, you can still figure out which quadrants. That's why radians is better than degrees. Okay, so what's tricky? It's the radians. You're not used to seeing pi as an answer, and you're not used to seeing fractions as part of your solutions. And you're not used to seeing multiple answers as one. You're used to only getting one answer. Now you can get infinite answers. Okay, let's do another example just to tie it in. Here we go. Let's try this one. This is your last one on the first page as an intro. This time I did cos. Same thing. Step number 1. You got to first work out which quadrants. Now cos. What is cos representing? X, Y, or gradient? Which one is it? X. Very good. So this means I'm looking at my X values. So just the X-axis. Just look at the X-axis. Now I'm saying cos of an angle is going to give you -1/2. So I need my X values to be negative. Which quadrants will I have my X being negative? Which quadrants? Which quadrants? 2 and 3. So this is where X is negative. Just on the X-axis, that's when it's negative. So that means any points in quadrant 2 and quadrant 3, that's where I will get x being negative. So pick one. Just pick a random point so you can draw and visualize the problem. Here we go. That's a random point. Here we go. That's a random point. So this x value, I want that to be negative half. That's all it means. It just means x is going to be negative half. So right here, the distance from here to here is negative half. That's it. That's all it's trying to say. So the x corner is negative half there, and the x corner is negative half here. Your job is now to do second step. What's my reference angle? What's my reference angle? So now you go through your exact values or your hand method. Cos of what will give me half? Cos of what angle will give me half? Have a think. 60 degrees. Whoever said that? That was 60. So cos of 60. So again, use your hand. You want cos to have one finger. Cos needs only one. Drop down this finger. That is your 60 degree finger. So it's pi on 3. All right, so now I know the angle, reference angle, this must be pi on 3 this way, and that must be pi on 3 this way. Because that's the angle. You have to rotate pi on 3, that acute angle, you have to rotate pi on 3 in order to have a horizontal length, cos, to be half. Okay, so now we've got pi on 3 this way, pi on 3 this way. Let's solve it now. Here we go. Cos inverse both sides. This cancels out. X is now equal to cos inverse of negative half. You told me the reference angle was 60 degrees, but radians. What's 60 degrees is radians again? Pi over 3. So I already wrote it. That's pi on 3. Now to know your answers, let's rotate. Here we go, starting from 0. I'm going to do a full revolution. So I'm rotating, and I hit my first solution, quadrant 2. But the first solution was only pi on 3 short of pi. See, if I only had an extra pi on 3, I would make pi. So to find that first solution, isn't it just pi short by pi on 3? So pi minus pi on 3. So here we go, my first answer. When I rotated from 0 and I rotated all the way here, I'm just missing pi on 3. So it must be pi minus pi on 3 is my first solution to get that one, that answer. How do you think I'm going to get my second solution? How do I get my second solution? All the way here is pi. I need to get here now. What do you do? How do you get here? So from there is pi. How do I get here? What do I do? Anyone have ideas? Yeah, that's it. That's all you do. You've got pi starting at this point. And we know that this is a distance of pi on 3. So if I just add by pi on 3, so pi plus pi on 3. Add your fractions. 1 whole take away a third gives you 2/3. 2 pi on 3. 1 whole plus an extra third gives you now 4 out of 3. There's my answer. Those are my 2 possible answers because these are the only 2 quadrants. And that's the angle that I'm trying to work out. I either did all the way up to this point, 2 pi over 3, or I go all the way pi with an extra pi on 3. That will give me my second point. That's in the 2 quadrants, and then make sure, if it's pi on 3, it will make sure that I'll get a half. That's my x value. That right there, if you understood even some level, that's combining A, B, C, D, E. It's all in one. It's a unit circle, it's exact values, it's symmetry properties. So if you got that, fantastic. If you haven't, you got to go back and think about your exact values or your symmetry properties, whether you need to understand a unit circle. All right? Can I get a show of hands who kind of understood, like about 50% of it? Show of hands if you understood 50. All right, good. 70? That's pretty good. That's not too bad. For the first time, that's a lot to ask. Okay, as you do it more, you get better at it. All right? All right, team, so that's what we do for the solutions bit. I'm going to do a few more with different x values and different numbers so that you can see how we solve the equation. That's the most easiest way to solve for now. Okay? Can you now take your second sheet of notes? We're going to flip over and we're going to jump to these examples here. Next session, I'll talk more about the graph. But for this session, let's do this one. This one should be easy now. Let's do this one. Example 1. Here's my graph. Y equals the sine of x. If you were to find x-intercept, how do you find x-intercept again? You let y equal to 0. So here I let y equal to 0. So that's my y, and there's my y equals 0. So can you see how it looks similar to our problem before? Except now it's equal to 0. So here we go. Sine of x equals 0. Sine inverse both sides. X equals the sine inverse of 0. And you go through the 3 steps I showed you just now. Step 1. Which quadrants? Shh. Thank you. Eyes and ears towards the board. Which quadrants? So step 1. Which quadrants will, now sine represents y values. Where in the unit circle will my y values be 0? Y value 0. So think about the y-axis. This is my y-axis. Where on the circle will you have it 0? So when I move around the circle, so starting from here, I move around, when will the y value be 0? There's 2 points that I can see. Yeah, literally. You got, at this point, the starting point right here, that's at 1, 0. So the y value is 0 there. And here's your second point. So it's pi, 0 or 2 pi. So if I asked you how many solutions are there, clearly you can already see. And the nice thing about this problem was you didn't have to do any add or subtract because it's clearly 0 is my first angle, pi, which is 180, so that's my second angle, and my last angle was 360, which is 2 pi. So you got your 3 answers already. Get me? So, or you can use the first acute angle, your right hand method. Which base angle did you have? You had 0. So then all the way here is pi plus 0, or pi minus 0, which is still pi. And all the way here, it's 2 pi plus 0, or 2 pi minus 0 is still the same. So between 0 and 2 pi, how many angles would it give you y value 0? You had 0, 180, and 360 degrees. Or translated to radians, 0, pi, 2 pi. Like Lucky said. That's my answer. Don't do it in degrees yet. Okay? In year 9, accelerated, they're doing degrees. But at this level, when you're at year 11 now, we work in radians. So we don't do it in degrees. Okay? Especially when they said x is an element of 0 to 2 pi, means you're working in radians. Okay? Had they said 0 to 360, then it's okay. But at the moment, we're working radians, so this is a bad answer. This is the correct answer. Okay, but I'm saying it in degrees to help you understand the unit circle. Let's try the next one. So 0 is easy. 0 is nice. You can visualize it. Let's try the next one. Same idea. So this time we've got, for the graph y equals 2 cos x minus 1. Again, if I want to find x-intercepts of this graph, I would let y equal to 0, and there's my y equal to 0. Now you'll see why it looks similar to the problem I did before. Here we go. Let's solve for x. Our goal is to solve for x. Add 1 on both sides. You get 1 is equal to 2 times cos of x. Divide both sides by 2. You get half is equal to cos of x. And that's what I was giving to you before. See, I gave you sine equals to root 3 on 2, and then cos equals negative half. That's what you're doing. You're practicing this bit. So let's solve it. Here we go. Cos of x is meant to equal to half. Step 1. Step 1. Cos represents x coordinates. So on your x-axis, you're asking now, when will x values be positive? Which quadrants? There are 2 quadrants. Where would x be positive? Which quadrants can I please have? Artie. Which quadrants will cos be positive? 1 and 4. This is the quadrant 1, 4. This is when x is positive. Only on that side. So that means there's two places it could be. It could be here or it could be here. But the point is x value is half. So the distance horizontally from here to here is half. Now you need to work out step 2. So we now know quadrant is 1 and 4. Step 2, base angle. What angle will give you half for cos? What angle? Angle of what, Numafi? Cos of what angle will give you half? Pi over 3, 60 degrees. Okay, so if you use your hand method again, hand method, I need cos to have one finger. Cos is on the right side, so if I only need one finger, I drop this one down. So if I drop that one down, that's your 60 degree finger. That's your pi on 3 finger. So I know the base angle is pi on 3. How does that help on the diagram? Diagram means that this distance, when you rotate there, that's pi on 3. And this distance here is pi on 3. I'm just going to do it in black over here. Q1, Q4. Why do you want to know how far they are? It's because now when you rotate through it, 0 to 2 pi, you can start at 0. Your first solution was pi on 3 from 0. So your first answer as you're doing this, x should equal to 0 plus pi on 3. That's one solution. So from here, plus pi on 3. And then I keep rotating to get to my second one. I go all the way, that's pi there. All the way here is 3 pi on 2. And then I go all the way here. I get my solution, but notice it's just 1 pi away, or pi 3 away from a 2 pi. It's just 1/3 away from getting 2 wholes. So you can just do 2 pi minus pi on 3 and you'll know what the leftover is. So 2 pi is the full circle. If you minus 1/3, you get the leftover. So the next bit must be 2 pi minus pi on 3. Let's work it out. This one is pi on 3. The other one, 2 pi minus pi on 3. So what's that? Working on fractions. 2 wholes take away 1/3. What do you get? 5 pi on 3. And that's my answer. That's my answer for a problem that involves solving circular functions. But can you see how I'm tying it all together? I'm doing unit circle, I'm doing exact values, I'm doing symmetry properties, which is 14a, b, c, d, e. So if you can do G, you've truly understood what I'm trying to teach you. If you don't understand what I'm teaching you, it means there's a certain section. Either you don't understand unit circles yet, or you don't understand exact values and symmetry properties. There's only 2 sections there. So don't work all 6 exercises. I want you to think about the theory and how you can apply it. And G is a really good exercise to do that. All right? You ready for the next example? And I'll probably stop there and then give you some time to digest it. Yeah? Let's do one where it has a lot of different numbers there. Flip over the page. Skip this one. You guys can probably do this one yourselves and practice. That one, all I changed was instead of 0 to 2 pi, it's 0 to 4 pi. So it means you do 2 revolutions. So you do 0 all the way here, that's 1 revolution. And then 3 pi, 4 pi. So there's more solutions rather than just 2 answers. I want you to look at example 4. This is as tricky and as hard as it can get. Why? I've changed the domain. It's now negative pi to pi. And I've got a 2 in front of the x. And I've got brackets and all the other. This is as hard as it gets. And if you can do this one, you've mastered 14G. Okay? This is the hardest one that you can kind of get in that scenario. Let's break it all apart. Same thing again. Okay? Don't worry about the period. I haven't taught you guys period yet. You don't need to know that for now. Let's think about this. Negative pi to pi. Okay, forget about the period. I'm going to show you a different technique and you can still solve it. Where's negative pi to pi? You have to visualize. So this is 0. Starting here, 0. That's 0 at this point. Remember, when you go anti-clockwise is positive, clockwise is negative. So when I say negative pi, where am I starting at? I'm starting there. That's negative pi. Okay, so I rotated this way, I'm starting at this point. That's where negative pi is. I'm going from negative pi to positive pi. So I'm starting from here, and I'm going to this point, that's negative pi on 2, to 0, to pi on 2, to pi. Okay, so I'm doing one revolution. Negative pi to pi. Okay, so that tells you where the starting point is. Unlike before, we were starting at 0 and we worked to 2 pi. Now I'm starting at negative pi and I'm working my way to pi. That's what the domain tells me. Okay? We're going to solve this. That looks nasty, right? Start off with the first question. Same thing. Who cares what this is? Doesn't matter what's inside the brackets. The point is, sign represents, again, x, y, or gradient. Which one is it? Y. This is my y values. And all I'm asking is, sine, which is y, when is it going to be positive half? So I'm really asking, where will my y values be positive? Which quadrants? Step 1. Step 1 was, which quadrants will I have y values being positive? Which quadrants? 1 and 2. So that means it must be the y value is positive over here. I need the y value to equal to half. So that means there's only 2 points. These are the only 2 points where sine can have a height of half. So quadrant 1 and quadrant 2. Q1, Q2. That's step 1. Then you've got to ask yourself now, you say, well, what's the step 2 is the base angle. Because you want to know how much did you have to rotate to get a height of half. That's what you're asking. So that's what the base angle is. So here, mathematically, all I'm doing is I'm doing sine inverse of both sides. That cancels out. So I should be up to this step where I have 2x plus pi on 3 is equal to sine inverse of half. So this is what I'm asking. What's my base angle? Sine inverse of half is the same thing as saying, what angle? What angle will give me half? So go through your exact values. Which angle will give you half? Sine of what? Sine of which finger? 30. Very good. So if you draw your hand again, you want sine to have one finger. So sine needs 1, so that means you have to drop this one down. That's your 30-degree finger. That's your pi on 6 in terms of radians. So that means my base angle is pi on 6. How does that change your diagram? From here to here is pi on 6. From here to here is pi on 6. So you've got pi on 6 this way and pi on 6 on that way. That diagram should help you visualize a lot at the moment. Okay? Now, let's answer the question. You still have this 2x plus pi on 3. I haven't taught you periods yet, so this one may be a bit tricky later, but you'll still get the process on how to do it. So from here, you have 2 possible scenarios. The first solution, remember, you started at negative pi. I'm rotating. I get to here, that's negative pi on 2. I don't get any solutions because the y values are negative. Then I get to 0, y value is 0. Right? So at that point, y value is 0. I then hit my first solution. This is when this angle I had to rotate all the way here. Right? Well, just that bit will tell me the angle that I need. So what angle is that? That's 0 plus pi on 6. Yeah? So I got the first solution is 0 plus pi on 6 because I went all the way here. There's no answers so far. And then I knew from 0 added by an extra pi on 6, it gives me my angle. So 0 plus pi on 6 is my first answer. I've got the solution for that bit. And then I continue rotating. I keep rotating and I rotate and I rotate. And I hit my second solution right here. This is the second time where the angle will give me the height that I want, which is half. But you already know this is pi and 6. And I'm just short of pi by pi and 6. See, I'm just short of pi by pi and 6. So it's easy to work out by just saying pi take away pi and 6. Let's simplify that. 2x plus pi and 3. You got pi and 6 here. What's pi minus pi and 6? Or 1 whole take away a 6. 5 pi and 6. And that bit there as well, some students will find troublesome because it's the fraction skills. That's 5 pi and 6. So that means from here to here is 5 pi and 6. From here to here is 5 pi and 6. Now, this normally would have been my answer. This normally is your final answer. And then you move everything across. Because remember in transformations when I taught you guys? Does anyone remember what happens when you change things to do with the x in the brackets? What does that do to the graph again? Does anyone remember? Asymptote, if it was has a graph that has an asymptote. But let's just say quadratics. If I gave you 2x plus pi over 3 squared, what does that tell me again? Does it tell me up, down, left, right, upside down? What is this inside the brackets? How do you work out what this does again? What does this do? Has everyone forgotten what this is? Maybe it helps if I said minus half on this side. What's the minus half tell us? It goes up or down. So this is down by half. So what's this one? Left or right? But I taught you a way to find out left or right at the start of the year. I taught you how to find left or right by letting this equal to 0 and then solving for it. Now if you solve for it, let's do this bit. Just solve for that. 2x plus pi on 3, if it equals to 0, what's x equal to? Minus pi on 3 on both sides. Cancels out. You get 2x is equal to negative pi on 3. X will equal to, divide both sides by 2. Hopefully you know how to do the fractions bit here. Negative pi on 3 divided by 2 is the same thing as timesing half. What does that minus pi on 6 tell me? Left or right? Left. If it's negative, it moves left. So this one tells me left by pi on 6. So same thing with sine functions. That's also left by pi on 6. But how do you see that? Right here. These are your first two solutions. Notice what happens when I try to solve for x. I'm going to minus pi on 3 on both sides. See, everything shifts to the left by pi on 3. But we said pi on 6 before. And the reason why is because I haven't divided by 2. If I divide everything by 2, it shifts to left by pi on 6. So this is saying left. This is saying left. Move left by pi on 3. So that cancels out. You get 2x is equal to, now this is a bit of mathematics here. What's 1/6 take away 1/3? Remember, you can't add or subtract unless the denominators are the same. Very good. So this one, to make it a 6, you have to times by 2. So it's essentially 1 take away 2. You get negative pi on 6. And the other one, times this by 2, times that by 2. So you're doing 5 take away 2 gives you 3 pi on 6. Now, the last bit is divide everything by 2. And this is where you have to be careful. X equals negative pi on 12. And then this becomes 3 pi on 12, which is really a quarter. But you haven't done anything wrong up until this point. Everything is correct, but the answer is not fully correct. Why? Yes, there is a left by pi on 6. This is left by pi on 6. So overall, you have moved left by pi on 6. But what? There was a hidden transformation. Anyone remember what that 2 does again? What does the 2 do again? What's the 2 do? It's a dilation. But remember, when you do a dilation in front of the x, it's a dilation. You're changing the x values, right? But if you change the x values, it's either horizontal stretch or horizontal compression. And with the 2, what's the dilation factor again? Anyone remember? Dilation factor of, be careful, this one. This is the one that chapter 7 a lot of students got wrong. What dilation factor is that? Hands up if you thought half. Because half was the end. Remember how with x it's the reverse? It's the reciprocal. So that one actually means compression. So why is that important? That means when you rotated before, you assumed that it was one nice full revolution. But if you shrink the graph, you actually do multiple revolutions in one same interval. That's where I haven't taught you yet on this graph. See that there? That's a typical sine graph. You go up, so you're rotating up to a maximum y value of 1, down to -1, back to 0, that's one revolution. But if you do multiple revolutions, you can see when you stretch or compress it, if I compress the graph within 0 to 2 pi, I actually can end up with multiple revolutions. This is for next lesson, okay? But that too makes a difference. So how do you do this problem? This is what I want you to do from this step. Before you where is it again? And this is a tricky one, especially when you haven't fully understood dilations yet. Just memorize this bit until later on for you to understand. You see how your period is between, where is it again? Your period was between -pi to pi. I think your life would be easier if you do this step. Right at this point, this is your final two answers. It's not wrong. It is correct. The only thing you have to add on, because there's multiple revolutions, that means there's a lot more answers. So how do you get all the other answers? Copy this formula down, and next lesson you'll understand why we do this. But period determines the number of revolutions. 2 pi on n. What is n? N is the number in front of x. So sine nx. Now, because in our scenario, n is actually equal to 2. See that? The n was actually equal to 2. That's my n. That means your period, how long does it take to make one revolution, works out to be 2 pi divided by 2 equals pi. Next lesson, you'll understand what this pi means. But what it means is that your final answer, in order to get a full answer, you must add and subtract pi to both of them up until you're out of the domain. So the domain said you can only work between -pi to pi. Keep adding and subtracting until you're no longer one whole in the negative direction and one whole in the positive direction. Now this part here is why students get confused, because you have to add fractions here. Because it's out of 12, how do you write plus pi? Plus pi is the same thing as saying plus 12 pi out of 12. So let's work it out. You had -pi on 12 and you had 3 pi on 12 as your two answers. If you add pi, that's the same thing as saying adding 12 pi on 12. What's -1 plus 12? 11. So you can have 11 pi on 12. But if you add this one by 12 as well, so adding an extra pi, you get 15 pi on 12. So that's my extra two solutions. Then you do the same thing for the backwards one. What if you minused it? Very good. That's within domain. That's within domain. That's within domain. And then now you go backwards. So you say, well, I added pi and I added pi to both of them. So these are your two key ones. These are the two answers you started off with. How did I get an extra 2? I added pi, but only one of them is still in the domain. The domain said pi. 11 pi out of 12 still in. This one's out of it. So this one you don't include. This one, you cross off. And you do the same thing for the backwards one. -1 take away 12 gives you -13 pi on 12. And then this one, 3 take away 12 gives you -9 pi on 12. Here's your extra 2. Which one can you include? Which one's still within the domain? Very good. This one's out. Okay? So your final answer You got negative 9 pi on 12, negative pi on 12, 3 pi on 12, 11 pi on 12. This is the hardest problem you're going to get. We're going to practice that more again. I don't expect you to know this one. Okay, so if you got lost up until this point, it's okay. Next lessons you'll get better. But what I do need you to be able to do is the ones before that. Before I gave you a dilation, okay, the dilation is what makes it harder. So if I didn't give you a dilation, you would have been done already. Okay, you would have been done at that point. That would have been fine. It's because once you put a dilation, you get more than 2 answers. Because the more revolutions you do, the more solutions you get. So instead of 2, we ended up with 4 possible answers. This one's a very hard one, and if anyone gets it on the first time, that's really phenomenal. It's not. I do not expect students who've never seen this before, who doesn't understand what period is, and to understand what I'm saying here. I don't expect that. Okay, but I do expect that up until this point, that makes sense. Okay, it's up until you learn the graph, and then you can then link them together. Okay, so for 14G. When you see these type of questions, the one with the 2 or 3 or whatever they put in front of the X, only do if you're confident with what I just taught you. I'm going to do that again next week. I'd rather that you do the ones beforehand. So everything that doesn't have, like these ones, I expect that you can do that one. I expect that you can do this one. These ones I think you all can do. Okay, so that's 14G. Find these questions. For those who have already learnt a bit on circular functions, then you need to be able to work on that example. These are typical year 12 exam type questions where they'll change the dilation and they'll change the period. So they'll do that, and you have to get more than 1 answer. Okay, so usually it's not 2. Most students leave 2. There's usually 4 to 6 solutions at year 12. Okay? All right, team, we're going to stop there. So like I said, that was the hardest one to understand, and I do not expect you to get it the first time. But you had to be able to understand up until this bit. Up to that bit, that makes sense. Dilation changes the problem. Okay, so this next bit is confusing. That's okay. All right, so work on 14G, or if you don't want to do DE, do G. If you want to work slowly, you've got time, then do DE and then G. But there's only 2 sections to learn. Unit circle, exact value symmetry properties. That can all be tied into one exercise. Cool? Now I'm going to stop the video there.